What if I told you the highest honor in mathematics was awarded because of a single needle? Would you believe it? More than a century ago, mathematicians asked what seemed like an incredibly simple question. A question so simple, almost anyone could understand it. But it took the world's greatest mathematical minds 108 years to finally solve it. And the person who broke the mystery was a young Chinese mathematician named Hong Wang. Imagine you're holding a needle. Your task is simple. Turn it so it points in every possible direction. How much space do you need? Most people would probably answer, that's easy. Fix one end of the needle and rotate it. It sweeps out a circle. If the needle is 1 unit long, the area is about 3.14. Then someone came up with a better idea. What if we rotate it around its center instead? The required area becomes much smaller. Then another mathematician suggested something even smarter. What if we move the needle while it's rotating? Now the area becomes even smaller. Everyone thought they were getting closer and closer to the final answer. They had no idea the biggest surprise was still ahead. In 1919, Russian mathematician Abram Besicovitch made an astonishing claim. He proved that if you move the needle in just the right way, it can point in every possible direction while sweeping out an area that is arbitrarily close to zero. The mathematical world was stunned. How could that be possible? If the area is almost zero, where does the needle even go? Many mathematicians were convinced there had to be a mistake. But decade after decade, no one could find one. The proof was correct. At that point, mathematicians realized they had been asking the wrong question. The area was no longer the interesting part. The real question became, does this strange object still occupy real space? Imagine a spider web. From a distance, it almost disappears. But as you get closer, you begin to see an intricate network of threads. It isn't just a single line. In 1971, mathematicians proved that, even though its area could be almost zero, it was still a genuinely two-dimensional object. But then an even greater challenge appeared. What happens when we leave the flat world of a sheet of paper and move into the three-dimensional world we actually live in? Could this mysterious object somehow collapse into something less than three-dimensional? That question challenged mathematicians for more than a century. Some of the greatest mathematicians alive, including Terence Tao, worked on it. Progress came painfully slowly. One breakthrough showed the object had to be at least 2.5-dimensional. Years later, another paper improved that result by only a tiny fraction, just a few digits after the decimal point. To most people, that sounds insignificant. But in mathematics, even the smallest improvement can be a monumental achievement. Because everyone knew the final step would be the hardest. Then, in 2025, a 127-page paper changed everything. Its authors were Hong Wang and Joshua Zahl. Together they solved one of the central problems of the three-dimensional Kakeya Conjecture. In simple terms, they proved something remarkable. This mysterious object can become incredibly thin, but it can never become anything less than truly three-dimensional. A wall that had stood before mathematicians for more than 100 years had finally fallen. 1 year later, Wang received the Fields Medal, often described as the Nobel Prize of Mathematics. She became the first Chinese national ever to receive the award. Many people ask, why spend more than a century studying a needle? The truth is, mathematicians were never really studying a needle. They were exploring the fundamental limits of space itself. Today, this kind of pure mathematics may seem far removed from everyday life. But tomorrow, it could help shape technologies such as medical imaging, wireless communications, computer vision, and artificial intelligence. History has taught us again and again the mathematical ideas that eventually change the world often begin with the simplest questions. Thanks for watching. And if you have a different perspective, I'd love to hear it. Share your thoughts in the comments below. I'll see you in the next video.